Okay, fifth graders, today we are doing Eureka Math Module 4, Lesson 10. Okay, I'm going to tell you that this week we're going to do Lessons 10, 11, and 12, and then have some review and stuff like that, and then you'll be ready for your mid-module test this Friday. Okay, so this Friday you're going to have your mid-module 4 test. Module 4 is not that long. We're already halfway through it, almost. Okay, and today we're going to continue working with what we know about multiplying fractions and whole numbers, but today we're going to be able to compare and solve expressions or equations that have parentheses. We're going to see how parentheses affects things. Okay, but first let's talk about the problem of the day. One way we can solve this problem is to draw a tape diagram and show that 3/5 of it were spent and 2/5 of it was saved. Yes? Then we can find out that in 240 altogether I've divided it into how many units?
5.
So 5 units equals 240. Therefore 1 unit equals 48. How did I get 48? Addison?
You did 240 divided by 5.
Very good. Then to find 3 units, which is how much was saved, right? 1, 2, 3 units was saved. That's $144. Then I found out 3 units were spent and 2 units were saved. So that equals 96. Then to find the difference, I had to do 144, the amount that he spent, and take away 96, the amount that he saved, and to find that the difference was $48. Okay. There's a second way to solve this problem. We know that 3/5 of 240 is what he spent. How could I write that as a multiplication equation? Nadav?
3/5 times 240.
Very good. 3/5 times 240, which is the same thing as 3 times 240 all over 5. Right? Can I solve it like that? Similarly, I know that he saved, or she saved, 2/5 of 240. How do I write that as a multiplication equation? Anirak?
2 times 240 over 5.
Yeah, you skipped one step. That's okay. 2 times 240 all over 5. And then I could subtract those two to find the difference. Yes? There's a third way we could solve this problem. I know that Bridget saved how much? 3/5 of her money. And she saved how much of her money? 2/5. So if we're trying to find the difference, could I do 3/5 minus 2/5? Which is?
1/5.
So the difference is going to be 1/5 of 240, which was the same as finding 1 unit, right? Which was 48. Okay, so we could have done that as well. So there's 3 different ways you could have solved this question. Very good. Today for the work that we're doing, we're going to be having tape diagrams and expressions and words. So there's going to be 3 ways that you're going to be able to write expressions. One is using a picture, a tape diagram. The second way is using words, and the third way is using numbers, okay? The directions here tell us to write an expression using words, then numbers that match the picture. So there's always going to be 3 different ways. They're going to give us one, and we have to write the other 2. Make sense? So take some time right now to draw exactly what you see. Don't do any math in your head. I know that you know that 9 plus 11 is equal to 20, but does it say 20 there? It says 9 plus 11. I'm going to show you why. So we know that 9 plus 11 is equal to 20, right? But the reason why we don't write 20 there is because we want to write the sum of 9 and 11. Do you see how what's given to us isn't 20, but what's given to us is the sum of 9 plus 11, right? The sum of 9 and 11 has been divided into how many equal units? 4 units, right? Which is why our unit size is fourths. Each of these is a fourth. Here's 1/4, 2/4, 3/4, and 4/4. And the brackets tell us that I'm looking for how many of those fourths? 3/4. Okay, so in words, I already did this part for you. The tape diagram shows 3/4 of the sum of 9 and 11. How would it be different if instead it said 20? It would be 3/4 of 20. But that's not what it says, okay? So make sure when you're writing your words that it really matches what the tape diagram says. Would the value of the answer change? No. But we just want to make sure that we understand, okay? Because when I start to write it with numbers, I know that 3/4, I write it like that, right? And then what does of mean in number form? Means what? Multiply. Good. 3/4 of. And then the sum of 9 and 11. Now, if I just wrote it like this, 9 plus 11, it's really 3/4 of 9 plus 11. That's not what we want. So we have to add parentheses that show that first you have to find the sum of 9 and 11. Does that make sense? If I didn't have the parentheses there, the words would be the sum of 3/4 of 9 and 11. Looking at the tape diagram, what would be the first step that we need to do? Add, what, 9 and 11, right? And so these parentheses show us that that's the first step that we have to do. Okay, let's go ahead and solve it. What's 9 plus 11?
20.
Oops. So this is equal to 3/4 times 20, which is the same as 3 times 20 all over 4. Okay? Now, we know that 3 times 20 is 60, and we could do 60 divided by 4. But we can also simplify our work. Do you guys notice how many factors are there in the top, in the numerator? 2. How many factors are there in the denominator? 1. Do you guys notice any common factors between those three numbers? Yes. 20 and 4 are both divisible by 4, right? So what that means is I could think in my head, I could divide this by 4 over 4. When I do that, what's 4 divided by 4? 1, right? What's 20 divided by 4? So I could, in my head, divide it by 4 over 4 to simplify the fraction first. So then my new fraction becomes 3 times 5 divided by 1, which is 15. Whenever you do that, you have to cross out the factors and write what it would be. Does 4 become 0? No, it becomes 1. Okay, be careful. We'll do some more examples to show you what I mean. We can think of each part of the words as part of the numbers. The 3 is the numerator. The 4ths is the denominator. It's the units. The word of is the multiplication sign, right? The word the sum of is the parentheses. 9 and 11 is inside the parentheses. So you can see each part of the words sentence has a corresponding part of the numbers expression. Similarly, each part has a role in the tape diagram too. The 9 plus 11 is the whole thing. The sum of shows that we have to do that part first. 3/4, 3 is right here, and 4ths shows that there are 4 parts altogether. Do you guys see that? Okay, very good. This time in this picture, are we given the whole and we're finding a fraction of a whole? No. What are we given? We're given one fraction of the whole thing, right? So if this green part is worth 1/3 minus 1/4, what is this blue part worth? What is this next blue part worth? What is this part worth? And so on. Good. So how many 1/3 minus 1/4 do we have? Okay. So in words, then, we know that we're finding 5 copies of, or 5 times of something, right? Do you guys agree? Are we doing 5 copies of 1/3 minus 1/4? Like, what would we have to do first in order to solve this problem? We'd have to do 1/3 minus 1/4. Now, the minus there, how do we say that? The difference of, I'm going to write it slanted because I'm typing, but you should write it, oops, it's not 1/3. Is it the difference of 1/3 of 1/4? No, it's and 1/4. What would happen if I kept it as of? What would that mean? Multiplication. Good. Consider this. What if I wrote it like this? 5 copies of the difference, 5 copies of 1/3 and, or minus 1/4. Okay, there's 2 different word forms. If I were to write it in number form, 5 copies of the difference of 1/3 and 1/4, this means 5 times, in parentheses, the difference of 1/3 minus 1/4. The bottom one would be 5 copies, right, of 1/3 minus 1/4. What's the difference there? What would we do first in the blue example? 1/3 minus 1/4. What would we do first in the red example? Allie? Yeah, is that what we need to do? So that's why this word right here, the difference of, is super important, because that gives us the parentheses. Without the parentheses, we would not get the right answer. Again, each part corresponds. 5 copies, 5 times. The difference of, parentheses. The difference of what? 1/3 and 1/4. Make sense? Now let's solve it. What do we need to do first? By the way, we established that this is wrong, right? Okay, what do we need to do first? 1/3 minus 1/4. Are we ready to subtract? Why or why not? The units are different. We don't have common units. We cannot subtract apples from oranges. It just doesn't work. What would be our most common denominator? Just like fruits would be the common denominator for oranges and apples. What's the common denominator here? Taya?
12.
Good. So I know that 1/3 is equal to some number of 12s. I have to think in my head, 3 times what equals 12? Times what?
4.
So what version of 1 should we multiply by? 4 over?
4.
So 1/3 is the same as?
4/12.
Good. Similarly, 1/3 is the same as 4/12. Similarly, what do I have to multiply to get from fourths to 12ths? 3. So 1/4 is the same as? 3/12. So the difference of 1/3 and 1/4 is? Good. Then I need to make 5 copies of it. Could I write times 5 right here and just add on? No, because 1/12 times 5 is not equal to 4/12 minus 1/12. It's very simple. All you need to do is rewrite 1/12 down here times 5. What is 5 copies of 1/12? 5/12. So we evaluate. When it says evaluate, it just means to solve. We evaluate this expression by solving it to find out that it's equal to 5/12. Let's first write it into numbers, okay? So what does product mean? Times. What are we multiplying? Okay. So we have 4 and 2. And we're finding that first, right? And the whole thing divided by 3. There's 2 ways to write divided by 3. You could either write the division sign, divided by 3, or we also know that we could write it as a fraction. Okay, so there are 2 possible ways to write this as numbers. So what does that mean we have to do for our tape diagram? It means that all together, we have the product of 4 and 2. And we're dividing it into 3 equal sections, and we're trying to find out how much one section is. Make sense? Go ahead and solve it.